Welcome to the Oregon Hatchery Research Center, a state-of-the-art salmon research facility located in the Coast Range in Oregon. The facility was built in 2005 as a partnership between Oregon State University and Oregon Department of Fish and Wildlife, and has been at the forefront of salmon research since then. ODFW provides a staff of 3 skilled fish culturists to care for the research animals in the building, facilitating research of all kinds. In the last 16 years, research has looked at all stages of salmon development, including how best to incubate eggs, how to sterilize fish for stocking in lakes, how fish navigate the streams and ocean, and how adults choose mates, and how to grow fish that are more like wild fish and less like traditional hatchery fish. When you visit the Oregon Hatchery Research Center and enter the building, you'll find the Interpretive Center. Here we have information about the life cycle of salmon, watersheds, the economic value of salmon in Oregon, and the role that hatcheries play in maintaining salmon populations in Oregon. We have displays of various species of salmon, both in their ocean phase coloring and their spawning phase coloring. And there are posters about the research that's been completed at the Oregon Hatchery Research Center. When you come to the OHRC as a researcher, you can get access to a cubicle in the research offices. So here we have space set up for you, tables, chairs, some information, some storage areas. So you can utilize this as a space for your project and for your project's things that you don't want to be bringing back and forth with you when you come out every day. Upstairs at the OHRC is a dorm. There are 24 single rooms in groups of 2, 3, or 4, and each group has a shared bathroom. Bedding is not provided, however, everything else is. There's a common room with cable TV, ping pong, and a full kitchen, as well as a laundry room. This is the dry lab, and it is set up so that basically when you walk into it, it's clean. When you leave, it's clean. Everything is labeled. And the reason for both of those things is that this is not anybody's home lab. This is a facility where you come and you do research. And because it's not your home lab, you don't know where everything is. So we have a list of things. If you need help finding something, you can ask the staff. And if we don't have what you need, we would be glad to order it for you. So this is meant to house anything that you might need. We have freezer space, we have a fume hood, we have chemical storage, we have a water purifying system. So we have pretty much anything that you maybe could need, and if we don't, we'd be happy to get it. We have microscopes and scales and all of the things that are needed here. This apparatus is a wine maze. So this was used by one of our researchers to test odor. They wanted to know if you put fish in the start box and put a different odor in one of the 2 arms, if the fish could tell, and if they preferred or didn't prefer that odor. So what they were doing here was they were testing an odor to be added to hatchery that has trouble with their returning fish. Lots of fish come back. They don't all come into the hatchery. And that's a problem. ODFW is not supposed to have their hatchery fish spawning with wild fish, and to ensure that that doesn't happen, we need to get them out of the system. So this project was going to identify, or did identify, an odor to add to the water that you could use to make a more unique olfactory signature for that hatchery. So if the fish were having trouble differentiating the hatchery from the creek around them, adding something to the water that comes specifically out of the hatchery during rearing should help adults go back there. So this project is no longer at the facility. They've been through the testing phases. They determined which odor they wanted to use, and they are currently at that hatchery using that odor in practice now. They're on the second year now, and there should be returning fish soon, so we'll get some information soon. The wet lab is designed to be changed, so we have 5 Canadian troughs we can bring in. We have picking troughs we can bring in. We have circular tanks we can bring in. And we can set everything up on its own water source. We can give it cold water, we can give it warm water, we can give it a mixture. We can bring water in from the floor, from Carnes Creek. We can bring water in from the ceiling, from Fall Creek. We have these behavior tanks where you can put fish in alone, you can put them in with others and observe them and see what's happening there. We have some fish in this trough right now. They were part of a project, and we also have heat stacks in the wet lab, and here again we can adjust so that each stack is on its own water temperature if we want, and so you can raise eggs in here. So we do most of our early rearing in the wet lab, eggs, and then pond into the troughs. And the troughs we tend to go outside into circulars. So there's a lot of variation in this room, a lot of ability to adjust depending on what you want your project to be. All of the water that comes into the building, specifically the wet lab, has to come into this room first. So you can see on the wall, there's 2 pipes. Those are from Fall Creek or Carnes Creek, so we can change where our water is coming from. There are 2 pumps on the floor. We need to go through one of those, but the second one is there for backup. So if one is broken, or if we need to clean the filter on one, we don't have to turn water off to the wet lab. We can simply redirect to the other pump and maintain flow. Then it can go to a drum filter, which is also set up to be run in duplicate. From there, it can go to UV filters. There's one below and one above. We're bypassing both right now, but it's the same deal. If one of them needs its bulbs changed, we can run it through the other one and not lose that cleaning purpose or power. Then it goes out, and it goes out through these pipes to a head box. If we want to, this is also where we'd run it through the chiller plates, so we can have warm water or cold water, depending on which water supply we're using. This is all part of the chiller, and then the main portion of it is here. And so we have the ability to heat water and cool it, depending on the requests of the researcher. At the OHRC, we feed fish to satiation. What that means is we put an entire week's worth of food into each container, and then if they're hungry on Monday, we feed it. If they're hungry on Tuesday, they feed it. If they're hungry on Wednesday, we feed it. And if they're out of food on Thursday, then so be it. They don't get fed again until the following week. We have very small numbers of fish here, so we don't have a ton of food, but we feed sizes, different sizes based on the size of the fish. So we have really small food for really small fish, and then it gets much larger as we get up to bigger fish. This is the tank farm. The tank farm has 28 6-foot tanks, 18 3-foot tanks, 5 4-foot tanks, and 7 12-foot tanks. There are so many tanks so that you can replicate things in them. When you're doing science, it's important that when you do something, it's replicable. So for example, if I were to do a backflip, which I cannot do, but if I were to do a backflip and land it, cool. I could say I can do a backflip, but is that true? If I try again, can I do a backflip? Maybe not. So in science, if you do something once and it works, you can't say that it's true. You can say that it's true if you do it more than once and you get the same result. So what we do with things here is you have multiple tanks that do the same treatment. If you get the same result in 2 of the tanks that have the same treatment, when put up against a tank that has a different treatment, then that tells you that you're probably correct. One of the interesting things about the OHRC that gives us some of our capabilities as research are some of the apparatus that we have. So for example, in front of us here is the electromagnet tower. In that tower, you can run current through the wires that are around it on the x-axis and the y-axis, and it will give you a magnetic field inside of the tower on top of these cinder blocks. What you can do is you can simulate any electromagnetic field that you would like. So for example, the way that this has been used most recently is you take fish from the Alsea Basin, which is where we're located here, and we have used the electromagnetic tower to create the magnetic field of the feeding grounds in the North Pacific. And if you tell the fish that they are at the southern part of that feeding ground, they will turn and move upstream, or turn northward to orient themselves back in the middle of that feeding grounds. If you tell them they're at the northern side, they will turn south to get back in the middle. So they used the tower to show that fish, when they're out in the ocean, they're using their the magnetic field of the Earth to determine where they are. And they used juvenile fish to figure this out, so this is a magnetic map that is in the fish right from the very beginning. So we think what's happening is fish, when they're hatched in the stream, they pick up on the olfactory cues of the stream. And you've all heard that before. You know, fish smell their way home. Salmon come back to the same stream where they were born, and they spawn there. So what that's telling us is they're spawning at home. They're hatching. They're imprinting on the odor of the stream. And then when they outmigrate to the ocean, when they get to the ocean at the outside of their stream, they're going to basically take a waypoint, like on a GPS, of what the magnetic field is at that location. And that way they're going to be able to find their way home again. The ocean is huge. There's no way you're going to smell your stream. But if you can find the magnetic field and get back there, then that's how we think they're doing it. Most recently, the hypothesis was that fish had magnetite somewhere in their body, and that's how they were reading the magnetic field. And to test that, the researcher used a solenoid, and he put the fish in the solenoid and gave it a pulse, which would reverse the polarity. So when he tells them they are too far south, instead of turning north, they would turn south because their magnetic compass is turned around. And they did find that to be true. So we're still trying to figure out where in the body that magnetite is. But we did show that magnetite is the mechanism. Other projects that we have done at the OHRC involve looking at domestication and how quickly that happens in a fish hatchery. So here, fish are put under different stressors, be it being fed every day versus to satiation, or having structure in their tank, or having flow in their tank. And all of these things are used to try to determine if they can slow down domestication or if it's actively making domestication happen. Some of the things that they've looked at as well include densities and ability to fight off disease. And this is a project that has used the simulated streams. So they've raised fish in the hatchery in these circular tanks, and they've also raised their siblings in the simulated streams, and then looked to see who is more successful at growing in the two environments. So sometimes they're able to look at wild fish and hatchery fish growth, sometimes just hatchery fish, but they want to know if different families are being more or less successful. This tank has flow, so all of the fish are swimming against the current. So again, do certain families do better under this condition, and is this a way that we can change how quickly domestication happens? One of the projects that we do all the time is working with the surrogate program. So they have been tasked to raise fish for the Army Corps of Engineers that are more wild-like than a traditional hatchery fish. So to do that, they feed them specialized food, and they raise them at pretty low densities in these large tanks with these structures. So the structure gives you the opportunity to hide and swim around them and kind of simulate plant life. So the situation with the Army Corps project is there's a lot of dams on the Willamette River system, and they were all built by the Army Corps. And anytime you build a dam, that impedes fish passage. If you impede adults from getting upriver to traditional spawning areas, then you need to mitigate for that by having a fish hatchery. The other thing that happens is you can put in a fish ladder to allow adults to go up, and then they'll spawn and you'll get juveniles above the dams, and those juveniles then need to be able to get back down. The Army Corps has been tasked with making sure that those juveniles can get down their dams successfully. And so that's one of the things that these fish are used for, is to test the ability of wild fish to get through the dams. Hatchery fish, having been raised in a man-made system, tends to be pretty good at swimming through man-made apparatus like juvenile transport or a dam, but wild fish seem to have more trouble with that. And so they use these fish that are hopefully more wild-like and use them as a surrogate for wild fish. We raise steelhead for that project here, And sometimes we do research with the surrogate program. They need to be able to show that the fish that they're raising are more wildlife than a hatchery fish and more like a wild fish. So they do behavior testing quite often to see if that's the case. And they often do that here. So the main things that they've done to try to create these more wildlife fish is using the structure, reducing densities, and then they use a lower lipid diet to more closely simulate what's available in the wild. They also feed to satiation, and not necessarily every day, trying to simulate a little more of the you found food today or you didn't find food today that happens in the wild. One of the perks of living at the hatchery and working here is that we live on station. And the reason for that is that we work on call. So because the system is reliant on water, and fish need water to live, somebody has to be here in case there is a problem with the water. So all of our staff lives on site, and we take turns working on call to ensure that everything continues running and works well. In front of us are the simulated streams. The OHRC is one of the only research centers in the world that has the simulated stream capability. So what this means is you can put fish in here, and it is as similar to a wild habitat as we can get in a hatchery. These are giant raceways that have been filled with gravel and shaped so that there are pools and there are riffles. And you can put fish in here as eggs, you can put adults in and they will spawn, you can put fish in as unfed fry, and you just let them go. And they will forage for food. If they're adults, they will spawn, eggs will hatch. They work really nicely. The setup is, right now there's 4 of these, and they're all the same. They are designed such that you could get in and adjust the flow or the design of the stream if you wanted to, and that has happened at times. You'll notice up above we have shade cloth. So because these are adjustable and changeable, you can't plant trees or plants in there like you would have in a real stream. So we have the shade cloth that will pull over in the summer to simulate tree cover. When we put fish in here, they are not fed anything commercially, so they find macroinvertebrates themselves and forage on their own. Inside this building is a drum filter. So all of our water at this facility comes straight out of Fall Creek, unless we're inside in the wet lab where it can come from Carnes Creek as well. So a drum filter is a way to remove solid things or large things from your water supply. So we do have one of those here on site. Under this black cover is the settling pond. This is another place where water comes in, and we use the settling pond as a place for the water to move slowly across this large space, and sediment will drop out of it. So it just helps us get a little bit cleaner water into the facility. Now, in front of us now is the adult trap. We have a fish ladder that goes around under this giant cover and then ends up under the tarp cover. And this is where we work through any adults that we get. We take fin clips for genetics and for isotopes, and we do length and species on the fish. If they're wild fish, we release them to continue on upstream. And if they're hatchery fish, we remove them from the system. We do not want hatchery fish in the system moving upstream. So fish are going to come up the ladder into this trap, and then we'll work through them in here. The last outdoor apparatus that we have is one of our most important, and that's our intake. So this is where all of the water for the facility comes from. We have screens that keep out any fish, larvae, hopefully any lamprey. And so this is an area where we keep all of our water coming in. It's really important that we keep it clear, and that has become a challenge in the last few years as we work through the landslide. Because all of our water comes from the intake and it comes from the creek itself, you get any of the pathogens or dirt or anything that is in the creek, you're limited in water amount and water quality by what's actually out in the wild. And so this is one of the more important parts of the facility. If we didn't have a working intake, then we don't have any fish. Research done at the OHRC focuses on the relationship between hatchery fish and wild fish, whether that be understanding the differences between the two or mitigating for the differences between the two. Part of that includes innovations in hatchery practices to reduce differences, and it also includes reaching out to the community and students and the public to educate about hatchery fish and wild fish and the importance of hatchery fish. Research that's been conducted here has been utilized all over the world as people understand how salmon behave more. The facility is committed to staying on the forefront of salmon research in these areas.